A good day to everyone who is watching. In our lesson 3 of the simultaneous equations, we are going to talk about the matrix method. So our first example, solve the following simultaneous equations using the matrix method. Our first example is 3x minus 5y is equivalent to 21, then 4x plus y is equivalent to 5. Now, we are going to extract the constants or the coefficients on the unknowns, the way they are, then we form a matrix. That is the 3, it is positive, 4 is positive, 5 is negative, then the coefficient of y there is a 1, then times the first unknown here is x, the second one there is y, is equivalent to 21,5. So we have formed matrices from those simultaneous equations. Then step 2, we are going to get the adjoint of this matrix here. Remember, for the adjoint, we said we interchange those elements in the leading diagonal. Then we change the signs of the elements in the minor diagonal. 5 was negative, is now positive. The 4 becomes a negative. Then step number 3, we are going to get this adjoint and then we left multiply it on both sides of the equation. So I've showed you that I'm going to multiply the adjoint on the left hand side of the equation. Then I begin to multiply those two matrices and also multiply those two matrices row by column, row by column. So here you need to know how to, first of all, know how to multiply the matrices, and then the adjoint, how to get the adjoint of a given matrix. So row by column, that is a 3, then plus a 3 plus a 20, then row by that column, that is negative 12 plus 12, then row by that column there, that is negative 5 plus 5, then row by column lastly, that is 20, positive 20 plus a 3, then times xy is equivalent to, here row by column 21 plus 5 times 5, 25, then row by column, that is negative 84, then plus the 15. Then when I add here, I'm having a 23, I'm having a 0, and a 20, 23. So when I add there, using my calculator, I should be able to get the 40, 46. Then when I add here, I should be able to get, negative 69. Then I again multiply these two matrices, row by column. So that is 23x plus 0, y times 0 is a 0, then x times a 0 is a 0, then plus 23y is equivalent to the matrices that side. Now we are having two equal matrices, that is the corresponding elements shall also be the same. So 23x plus 0, we get the 23x, that it is equivalent to 46. Then I divide both sides by 23 and that way by 23. So I get my x value when you divide using a calculator, that is a 2. Then the same applies there. The 23y is equivalent to negative 69. Then I divide both sides by 23 and then I divide both sides by 23. So y is equivalent to a negative 3. Therefore, the x value is 2 and the y value is negative 3. So when we are solving simultaneous equations, our answers can be positive, can be negative, can be fractions. We are having example 2, as simple as that. Now, when you look at the would-be first equation, is that the unknown of y is on the other side of the equation. So I must first take it back here. That is the 3y, so the 3x, then minus the 3y, that it is equivalent to 34. Then the 3x minus the 4y is equivalent to a 5. So I have that. They are in the order, the unknowns. Then I form a matrix 3, 3, negative 3, negative 4. Then times the first unknown there is x. Then the second one is y. 34, 5. Then I get the adjoint. Elements in the leading diagonal, they interchange position. Then elements in the minor diagonal, they change the signs. Then I left multiply on both sides of the equation this adjoint. Multiplication, row by column, as I'm adding. Now I'm going to be speeded because you should be able to go back to the videos of matrix multiplication so as to see how we multiply the matrices. So this is going to be negative 12, then plus 9, then negative 9, then plus 9, row by column, positive 12 plus negative 12, a positive 9, then plus a negative 12 times xy is equivalent to, here when I multiply using a calculator, that is the negative 1. Then row by column, I add on the 15. Then row by column, that is the negative 102. Then plus again a 15. So when I add there, I get a negative 3. When I add there, I get a 0. When I add there a 0, negative 3. Then times xy, which is equivalent to, when I add there, negative 121. Using a calculator, when I add there, I get negative 87. Then again, when I multiply here, I'll be having negative 3x minus 3y. From the previous example, we have said row by column that this one is going to be 0. So 0 plus the negative 3x is the negative 3x. Then equal matrices, corresponding elements are equal. Negative 3x is equivalent to negative 1, 2, 1. Then divide both sides by negative 3. So I get the x value as 1 to 1 all over 3. Then here negative 3y is equivalent to negative 87. Divide both sides by 3, negative 3. I get y as 29. So that is our last example. X plus 3y is equivalent to 15. 3x plus 2y is equivalent to 17. Very fast. We make matrices all over. This is 1 coefficient, 3, 3, a 2. The first unknown there is x, then y is equivalent to 15, then 17. Then the adjoint is equivalent to, we interchange the leading diagonal, change the sign in the minor diagonal, then multiply, left multiply the adjoint on both sides of the previous equation. Then when we multiply this side, we get the negative 7, 0, 0, negative 7, then times the xy, which is equivalent to negative 21, negative 28, then row by column again, that is negative 7x, negative 7y, is equivalent to negative 21, negative 28. So the negative 7x is equivalent to negative 21. Dividing both sides by negative 7, I get the x value as a 3. Then the negative 7y is equivalent to negative 28. Dividing both sides by negative 7, I get the y value as a 4. So therefore my x value is 3 and the y value is a 4. So try out those numbers, then you will be giving me a feedback.